Hey everyone, we're back with another episode of the ARIO Gateway Ops video series. Last episode, we made some huge progress and actually set up and tested the gateway on our Raspberry Pi. It's indexing L1 transactions, caching data, and serving us GQL results over HTTP using its local IP address. Now, for this personal gateway, I want to be able to access and share all the data I have uploaded, along with some of my favorite dApps like Arweave. Now, even though I can already do this with my gateway now, I still have this ugly IP address without the security of HTTPS and without any friendly names for my Arweave data. So in this episode, we're going to perform some final configurations, like creating a wildcard certificate with certbot, using Nginx for SSL termination, and setting up my domain name with the Arweave Name System. We already installed all the tools we're about to use, so it's just a matter of using them. Let's get into SSH and continue. All right, so I'm connected to my Raspberry Pi, and we can see that it's still running and syncing from when we set it up the other day. Let's stop it for now so we can make some changes. I'm going to run the following to stop all running Docker containers. Now, even though I can access my server by its IP address, those are pretty difficult to remember, and it could change over time. And let's face it, nearly everything everyone accesses on the internet uses some friendly, easy-to-remember domain name. So we're going to have to get one for our ARIO gateway. There are many traditional, as well as a few Web3 native, top-level domain name providers out there that you could use here. It doesn't matter if it's a .com, .io, .nft, as long as you can set DNS records, you should be good to go. To set up your DNS correctly for an ARIO gateway, you're going to need two DNS A records that both point to the externally accessible IP address of your Raspberry Pi. One record has to be created at the root of your domain, and another using a wildcard symbol, with whatever TTL of your choosing. I typically go for 1 hour. Once those are set, just leave open your DNS provider's website because we're going to come back here in a little bit. Now for HTTPS, we're going to need a wildcard certificate. Wildcard certificates are important because this ensures I can use HTTPS at my second level domain and all third level subdomains. Let's just take a minute to explain a couple of the things that subdomains are used for by an ARIO gateway. So first, when a browser requests a transaction from the gateway returns a redirect to a similar URL, but with a new label in the subdomain. This label is a base 32 pseudo-unique address derived from the transaction ID. As the transaction is now being served from the subdomain, the browser's same origin policy is invoked, and the web page is restricted to this sandbox. This gives the browser its own secure context for communicating with the gateway. Subdomains are also used to serve names registered in ArNS, the Arweave Name System. ArNS simplifies the navigation of the permaweb by enabling user-friendly names that link to permaweb apps, pages, data, and identities. Even if we apply our domain name to our gateway, I would still have to share links with long Arweave transaction IDs in the URL. Nobody wants to see those in their feed. Each ARIO gateway can act as a name resolver and will serve names as subdomains underneath that gateway's domain name. Now that I've secured a domain name, I'm back on my terminal. I'm going to leverage certbot to generate a new wildcard certificate for my gateway. For this test, I'm going to use the domain name gatewaypi.com. So make sure to update this command with your domain name that you've purchased. Certbot's going to ask me to add a new TXT record underneath my domain so it could verify that I actually own it. I'm going to do this quickly at my domain registrar's website. Once I do that, I'll finish the creation of the certificate and it will be placed in the default certbot location at /etc/let'sencrypt/live. Now it's important to note that this is a free process and the certificate will expire after 90 days. You might want to do something a little bit more long-standing if you're doing this for a production use case. Next, we're going to leverage this certificate in Nginx. Nginx is open source software for web serving, reverse proxying, caching, load balancing, and more. We're going to use it to terminate our SSL connection and proxy requests to our gateway, which, if you recall, is using Envoy on port 3000. Let's open and edit the configuration file for Nginx. We're going to add the following to redirect requests from port 80 to port 443, along with setting the path for our SSL certificates, which are currently located in their default folder from certbot. So now let's save this configuration and test it out with sudo nginx-t. Okay, so there are no errors. That means we can restart the nginx service with sudo service nginx restart. Okay, so now our domain's ready to rock, we have SSL certificates in place, and we're able to accept traffic on port 80 and 443. Let's just make a quick change to our gateway's environment configuration to add support for HTTPS sandbox requests as well as ARNS. We'll open up the file and add our domain name as the ARNS root host. Next, we'll change sandbox protocol to HTTPS. Done. So let's save it and start the node. We'll use sudo docker compose up -b --build. Since we already set up port forwarding on our router for port 80 and 443, our gateway should be immediately accessible using our domain name as well as through ARNS. Now let's give it some tests. So let's open up our browser and check some transactions using our new domain name and HTTPS to see sandboxing in action. We can load a few different transactions and see how they're redirected to include this sandbox subdomain. Okay, looks like it's working just as expected. Now let's try out a few ARNS names. Our gateway will resolve and cache each name and its data after I access it. This ensures future accesses are faster and entirely from my device. And just in case you needed to check which transaction ID the name is being resolved to, you can always check using your browser's DevTools and look for the ARNS resolved ID. So as you can see, it's easy to remember the link to anything on the permaweb using your gateway along with ARNS. My Raspberry Pi personal gateway is nearly finished, but I still want complete control over my data by also maintaining a local index of all my transactions. Even though my gateway will automatically index every layer 1 transaction, it won't pick up the bundled data that I've uploaded. Next episode, we're going to show you how to configure ANS 104 bundle indexing and create a personalized index of your permaweb data. Having a blast following this tutorial? Let us know about it and share your gateway's URL below or in our Discord. We'd love to hear from other gateway operators. Thanks for watching today's episode, and I'll see you again soon.